Hello, this is Jim Henson, not Jim Henson, the hand behind the beloved characters of Channel 2, including Brock the Sock, Hitchcock the Sock, and of course, Elfo. There has been a little trouble at the station lately related to overextension of the directing team. Fortunately, no one has died yet, though some of our Plante friends have been on the slow march toward it. Interestingly, demonstrated by the very same plants of the station, we can directly observe the struggle for life as determined by suboptimal conditions and failure of regulation. For instance, this Chinese evergreen demonstrates the failure to absorb the provided water adequately, causing some signs of root rot, as can be seen here and here, not to mention the roots. This failure to absorb water is related to metabolic insufficiency. This plant is limited to poor sunlight. Thus, its photosynthetic process does not absorb water very quickly, despite being a tropical plant. We can also notice that this plant has accessory pigmentation in the leaves, particularly noticeable here. I'm not sure why it won't focus for me. But, anyway, it is not immediately clear that these pigments play a role in capturing photon energy, or if they've been selected for simply cosmetic reasons. A much more interesting plant, for a different reason, demonstrates the so-called behavior of plants of being toward light, or phototropism. This used to be a little fiddle leaf plant. Now it's quite a large fiddle leaf plant, though it is still considered little. It has been in the studio's care for 3 years now. It has grown up in many different spaces, including one in early development where this plant was frequently sunbathed, explaining some of its impressive growth. However, since being moved to a different spot, it has grown taller and lopsided. A typical explanation of this kind of movement would be to say, the plant has grown taller because it is reaching to a better lit area of the window to avoid the neighboring studio's shadow. It has grown lopsided because it has grown into the blinds, maximizing its exposure to the sun. Such explanations are just fine and might convince young children that it's just that simple. However, we know that plants don't have neurons, meaning we cannot reduce this phenomenon to cognitive processes. Luckily, the science is out. The phototropism demonstrated by this plant is thanks to an auxin or plant hormone known as indole-3 acetic acid, henceforth referred to as IAA. If you're well caught up on your organic functional groups and amino acid recognition, you might remember that indole is the R group of the amino acid tryptophan. Amongst several other biosynthetic pathways, tryptophan degradation is a known method of deriving indole-3 acetic acid. It should also be remembered that using amino acid derivatives for hormones is well established in the animal kingdom as well, including tryptophan for mammals, which is developed into melatonin. In plants, this auxin, again, indole-3 acetic acid, henceforth IAA, plays an interesting role. In response to sunlight, IAA on the light abundant side is generally degraded, but on the light deficient side, the auxin collects. The auxin then binds to an AuxIAA protein, which is previously inhibiting the auxin response factor. When these AuxIAA proteins are bound to the auxin response factors, it prevents transcription of auxin-related genes, including the code for auxin response factors themselves, and IAA proteins. When auxin binds to the AuxIAA protein, they're both marked for ubiquination, freeing the auxin response factors to transcribe the DNA associated with high auxin levels. This change causes a cell elongation response, including the unequal development of stalks and stems, appearing as if the plant is deliberately growing into the sun. As we can see in this studio's plant, it can cause some seemingly self-destructive growth. This plant cannot easily support its own weight. Self-destructive or not, it cannot be said that this plant has failed in terms of regulating its own growth. But what if indole-3 acetic acid wasn't easily degraded? What kind of response would that induce throughout the plant? We see this precise question answered by the potent herbicide 2,4-dichlorophenoxyacetic acid, or 2,4-D. An immediately recognizable difference in structure can explain why it is recognized by the plant as hormone, but not degraded by the plant as hormone. It is not an indole. The nitrogen of the indole site has been replaced by a chlorine, suggesting electronic similarity in active site. This chemical was used as one half of the infamous Agent Orange, applied to Vietnamese vegetation so that the plants would effectively stop transcribing auxin response genes. So that they would not stop transcribing auxin response related genes, overgrowing and elongating the plant until it is starved and dead. This genocidal tool was quite effective in killing not just plants and not just killing plants to kill human beings better, but also as a human being killer directly. A small impurity in the mixture still results in horrible health outcomes for the Vietnamese people. As for this plant, it may need some diffusion of auxin response so that it can evenly grow. In order to do this, yours truly will simply have to rotate the plant after rebuilding the support structure which was necessary to initiate such a change. Before I finish, I would like to demonstrate to you, the viewer, what kind of leaf growth it looks on the auxin abundant side versus auxin deficient. Here we see this uneven growth pattern in the leaf. This is the side of the leaf which directly faces the sun. Here we see the opposite. This leaf is evenly grown. We can also see differences in the waxiness of some of these leaves. This leaf is quite waxy, very healthy looking. Meanwhile, this leaf is not so much, and some of these are even worse. To demonstrate exactly how weak this plant is to support its own weight, despite having quite a few days of me attempting my best with it, I'm going to move it further away from the window. As we can see here, this is not a sustainable practice for this plant. This is not good. And this is, of course, because this side of the plant, which has grown unevenly, has had too much auxin that has not been degraded. And these stalks, have not been able to grow meaningfully, only elongate. Thank you.